Hello, this is Steve Bell for the MedTech Mavericks podcast, and today we continue our series on surgical soft tissue robotics. And today I'm going to talk about a really exciting robot, which is the Moon Surgical Maestro system. So let me start this podcast today with a discussion around different types of surgical robots, because so far I've talked about in the other podcasts about Hugo Raz, and I've talked about the Medicroid Hinatori. And they are what are considered by some to be mainframe robots, which is they are, you sit at the console, they have a major boom next to the bed, and basically they are teleoperated systems, fully capable with multiple arms. Whereas today I'm going to talk about a slightly different segment that I think Moon Surgical has a potential to lead on. There are different ways that you can use robot arms, and some of them can be, as I talked about on the mainframes, hanging them off a boom or putting them on carts around the table and operating them from a console where you sit down. But other robot arms have been around before. There's been things that are known as things like SCARA systems, which are they're selective compliance systems where you use the arm in a different way. And this is really getting into a topic which is about cobotics or cooperative robotics and soft robotics. And it's also a little bit about you can use a robot arm as for example, a scope holder. And there's many companies out there over the past that have done this as scope holders. But you can also use them as instrument holders. And you can go back to the late 1990s, early 2000s, and you can look at Leonard Medical Inc. that did a system which was a scope holder and an instrument holder, and it was a passive robot. It was a SCARA system, and it held the scope and it held the instruments. So using robots in this way, where you don't sit at a console, is actually not a new concept, but it's an interesting concept. So what this allows is it allows for an assistance in laparoscopy, which is different than what you would have as the classic robotic assistance. You're not sitting down at the console. This is a bedside assistance that somehow frees up your arms. It allows you to hold the scopes, and it allows you to hold secondary instruments. And I'm going to dig a little bit deeper on why that becomes a very important paradigm within laparoscopy. And it's really what I want to talk about is this whole segment of advanced or assisted laparoscopy with the use of robotic arms to allow that assistance. So before I jump into Moon Surgical and Maestro to tell you about that actual system, I just want to tell you a little bit more about the concept of advanced laparoscopy or assisted laparoscopy. So in certain settings, it's difficult to get good assistance. And sometimes there's just no assistance available. So if you've got three instruments, one for your left arm, one for your right arm, you've got another instrument that needs to be holding something or retracting, so you need a second person to hold that, and you need somebody to hold the scope. So often the assistant will hold a third instrument in their left arm, and they will hold the scope in their right arm. And that's kind of how you work in laparoscopy. There's the primary operating surgeon and the assistant surgeon that work together to do this dance of instruments. Well, firstly, there's not always available an assistant. And in some settings, in some places like an ASC, the primary surgeon would have to pay for a secondary surgeon to be there. There's also the fact that sometimes you'll get a bad assistant. So you get a very junior doctor who doesn't quite know how to retract correctly, and they're manually holding the scope. And I'm going to talk a lot about this, about the real necessity for scope holders. And they have been around for a long time, but the reason why you need it in modern advanced assisted laparoscopy, and especially I'm going to talk about that with regards to 3D vision systems that have to be rock solid. So if there's a need for an assistant within laparoscopy, then you can do that either by having a manual human assistant, or, and this is what Moon Surgical is about, can I bring in some robotic arms to replace that other individual? And the answer is yes. Again, I said it's been done before with Leonard Medical. It's been done before with ESOP. It's been done before with many other systems. But Moon is different, and I will really get to that in the way that they've made this happen. And it's shocked me and surprised me a little bit on how they've done this. But the concept is that in an assisted laparoscopy, I have a scope holder that will hold the scope steady, and I have a retraction device that will hold the retraction instrument steady, and that allows my arms as the primary operator to be freed up so that I can focus in on using my left arm and right arm to do dissection and manipulation using the two primary instruments. And that's really what this space is about. How do you help laparoscopy to be done either as a solo surgeon or as an assisted? And this is really going to play into places like ASCs or outpatient departments or hospitals with shortage of staff. And it's also going to talk about, which is one of the primary things that this is really going to change, is about procedure efficiency, speed, and workflow. So in modern laparoscopy, and as we go forwards with robotics and different digital health, one of the other key things that you're going to want as you assist in laparoscopy is to give some of that rich data back to the surgeons that you do get with a full-scale mainframe robot. That is just going to become table stakes for everybody, that your system has to allow integration into a digital architecture. So again, when we talk about Moon Surgical, I'm going to talk about how they've done that in a very clever way, which is, again, I wasn't expecting, and it was a pleasant surprise, but I'll dig into that deeply when I talk about the system, and it'll make more sense. And what are you trying to get with that rich data? You're trying to get forces that you're putting on the instruments. You're trying to get visual data. It's very helpful if you can work out some things like patient setup and port placements. And that's going to be one of the things I'm going to talk about with Moon Surgical and Maestro, which is quite interesting and novel. So what is the system? Well, first of all, there's no sit-down console with the Moon Surgical system. The Maestro system is basically a cart with a very smart interface. And on that cart are two arms, and they have different lifting mechanisms and positioning mechanisms to get the arms into an optimal position around the patient. What I noticed about the arms straight away was just how small, thin, and light they were. And that made me realize that the payload that they're working with, they're not trying to use the arms to lift heavy tissues, which is very different from a lot of the mainframe robots. With the mainframe robots, you've got payloads on there that you're going to have to lift to be able to actually manipulate tissues, let the actual robot arm manipulate the tissues. So the first major paradigm difference is that Maestro is not about making a strong, robust, heavy arm that's going to be lifting tissue. Instead, what it's about is stabilizing and allowing the instruments that you're using on it to be stable in space and float in space. And I'll come back to that later, because they've done this in a really interesting and clever way. So if you look at the arms are very much looking like robotic arms, but much thinner and much slimmer. The interesting thing is, though, that the last few joints are just passive. They're not active joints, and that's really important about putting loads onto the abdominal wall via the trocars. On the terminal joint of the Maestro arms, you have a connector. And what does this connector do? It's a magnetic connector, and it clips onto the arm so that you can now clip the magnetic interface onto each arm. And those interfaces, you either have a 5mm shaft interface or you have a 10mm shaft interface. And they're like a V mechanism that allows you to slot a shaft of a standard laparoscopic instrument, either a 5mm or a 10mm instrument, and that can be any length. That can be standard length or bariatric length. And what you can also do is, if you've got a 10mm, you can slot a 10mm laparoscope into there. So that means that you can have the arms hold a laparoscope or an instrument. And that's what this is primarily aimed to do, is to give that assistance and to replace the bedside assistance by having one arm for the laparoscope and one arm for the instrument. So what does the user do? The user basically, they put the laparoscopic instrument into the shaft adapter, and then they use it like a standard laparoscopic instrument. There's no docking of the arm to the ports. There's no docking of the robot to the patient. What you've done is you've attached the arm to the instrument. And let's focus on the instrument first off, and then we'll talk about the scope later. What that allows you to do, and this is where you start to see that something's very different about Moon Surgical and the way their arms work, is that you don't position the arm by holding the arm and moving the arm. You put your fingers into the laparoscopic instrument as you would do with any standard laparoscopic instrument, and you use the instrument as if there is no arm attached. And you can move your instrument around, and the arm is so fluid, and there's no huge force required to move the arm around. And as fast as you want to move your laparoscopic instrument around and get it into the patient and get it into position and grab some tissue and then move the tissue out of the way, the arm it follows what you want to do immediately. There's no forceful back driving of the arms. And that is the real difference that I saw between this and any other system that I've seen as a soft robot. It's amazing how they've done this, that it's so fluid and it's so little force. But then what happens is, and this is the clever piece, the minute the operator then lets go of the instrument, the arm holds it perfectly in place. Let me say that again. So you put your instrument, you attach it to the arm, you then use your instrument as if it's a standard normal laparoscopic instrument, and the arm follows you. When you let go of the instrument, the arm understands that you're no longer driving the instrument, and the arm then stays in place. It's gravity compensated. It just holds the instrument where you left it. So that allows you to position very easily and fluidly. If I take the instrument again and reposition it, I don't need to press a button to change it into that mode. It just knows, the system works it out. So that is a huge difference. Same with the scope. I attach the scope, I put the scope in exactly as I would with a normal laparoscopic movement. And I position the scope, I move it as easily and as fluidly as I would with a normal laparoscopic scope. The speed, the movement, the forces, it's all the same as if you were just having a free-floating laparoscope in your hand. But the minute you let go of the laparoscope, the system takes over, understands you've let go, and it just holds it in place, rock solid. That is a massive difference to any other system that I've seen before or I've interacted with before. So I think that that's a really interesting paradigm, and I'm going to tell you why that becomes very interesting for laparoscopic surgery. I've tried to help you understand how these arms are very different than a mainframe's arms or any other arms that I've seen out there before. But I also want to talk a little bit about their cart system, which again is completely unique to anything I've seen before. So the cart system has on a screen and a setup screen. And what they've put on there is a set of 3D cameras. It looks kind of like sort of a Dyson Airflow thing that sits on the top of it. But those cameras are looking towards the patient and the room. And in 3D, what they're understanding is they're understanding the patient position, the table position. They're understanding where it sits in the operating room. And as you move the cart around, the graphics on the cart screen show you your 3D location in space with relation to the table, how the table is set up and how the patient is set up on the table. So that in itself is pretty impressive. And as you move the cart forward towards the table, in real time, it's recalculating and re-showing you in the graphic the setup. So that means that Moon has made it so that the Maestro knows where the Maestro is in relation to the patient. And then they go one further, and this is what I found quite clever. So they're able to, in real time, basically be 3D scanning the shape of the patient's abdomen as it's insufflated with the trocars in it. And not only that, what they've worked out then is where each trocar is on the patient's abdomen in relation to where the Maestro is. And why that's important is to do with setup. So if the cart knows where it is in relation to the table, in relation to the patient, and it sees the patient's abdomen, and it sees where the ports are in the abdomen, then through calculation, it can work out where your best arm setup is going to be for the scope, and your best arm setup is going to be for the retracting instrument. So Maestro allows you, by using this 3D image, to position the arms in the initial setup so they come right into the area and the zone and the position and the angle, which is optimal for that patient at that cart distance, on that table, in that patient position, with that trocar configuration, and how their abdomen is distended under that insufflation, because every abdomen distends differently. If you put that into your head, what that means is this makes it supremely easy to position the cart and get the arms ready for surgery. And what that translates to in the surgeon and the hospital benefit is that magic word that is going to be needed for so many different locations: workflow. The Maestro, without doubt, will improve surgical workflow because it helps you to do the whole setup intuitively and through its own camera systems. And that to me was where the light bulb went off in my head of, okay, that is extremely different. And now you make it so that you have this very simplistic interface between, and I'll say simplistic, and I apologize to the engineers there, and I apologize to Anne and Jeff. I don't mean simplistic in terms of design. What I mean is simplistic in terms of use. The methodology to use it is so easy to use. Anyone who's done laparoscopy, they can use the Maestro. It's that simple. And that, I think, is one of the big changes. And then, in fact, they said to me that there's no training as such as you would do with a mainframe robot. You don't have to go off site and learn to train it and all the safety systems. Basically, this is just assisting laparoscopy. So if you can do laparoscopy, you can use the Maestro. So therefore, it's a couple of hours in the hospital, bedside, just teaching people how to, turn the cart on, how to turn the cart off, how to take the adapters off and on. Super simple. And because they don't have their own instruments, which are pros and cons, you don't have to teach a CSSD how to do all the sterilization because they're using their standard off-the-shelf instruments. So the second light bulb that went on for me with Maestro is getting this into a hospital up and running and having people use it. And this is about workflow again, adoption of the technology. I don't think there could be an easier robot that I've ever seen to be adopted this way. And I think that's, for me, one of the things that I took as a spark of genius is if you make it so simple to introduce this system into the hospital, make it super easy to set up for the patient on each case, adapted to the patient, and make it incredibly easy for the bedside user, the surgeon, to just click the instruments on and go with laparoscopy, you've smashed down several of the barriers that mean that places like ASCs would struggle to get a robot to use on a daily basis. I think this, for me, is one of the first systems I've seen that smashes that barrier. And that, I just think there's something in this. I am going to go back and just stress again that you have to really see it to understand it. But the fluidity and the buoyancy of the arms is so impressive. And the lack of force required to move it around and back drive those arms is really clever. So that's really important. The downside a little bit, though, of remember when you don't have your own instruments and you don't have your own camera system, let me talk about that a little bit. So if I have a really old, bad 2D camera system, the image quality I'm going to get is whatever my camera system is. Now, it's not worse than what I do in laparoscopy, but compared to a state-of-the-art mainframe, I may have a much lower capability vision system. So I may not have ACG, it won't be 3D, and it can be a bad, poor image quality if that's what I have in the hospital. If I have a 3D 4K Rubina system, then great, you now suddenly get the whole Rubina to be able to be used on there. So you've got your ICG and you've got your 4K and you've got your super high definition imaging and all your different imaging modes. But you're at the mercy a little bit of having to deal with whatever camera system is in there. And again, the compatibility issue becomes more of an issue as you have more systems that you need to be compatible with. And you have to quite often have a compatibility list. But if you don't give 3D, that is one of the big things that people who would be looking for a robot would be after is 3D vision. One of the things is if you're taking a Maestro system and you want the 3D vision, then you can get a 3D camera system and you can use it with it. But you might have to buy that as an extra from somebody else. The one massive benefit of something like a Maestro as opposed to having a human assistant hold your camera is I can't explain to you how much of the 3D system in a mainframe robot is not just the 3D vision of the system, but it's the stability, the rock steady stability of the system. And with Maestro, you get that. And that means that you can get that beautiful 3D non-nauseating imagery with the Maestro system. The second disadvantage of not having your own instruments and vision system is that on the instruments, a major reason that people buy robotic systems, again, is for the wristed architecture of the instruments. And if you're using your standard straight stick instruments, if you have bad straight stick instruments, the sensation of what you'll get is no worse than your laparoscopy, but you won't feel such a massive benefit of the system. So again, you're a little bit at the mercy of whatever laparoscopic instruments you have, and that's good and bad. If they're really good and I use them every day and they work well and I know how they work, it's immediate my ability to use them on the Maestro. But if they're bad and you're using the Maestro system, there could be a temptation for the user to feel that they're not getting a great user sensation from the Maestro, when it's got nothing to do with the Maestro. It's got to do with the fact that they're using their poor instruments and their poor vision system. So that's a risk for any system that doesn't have the A to Z of the integration with instruments, vision, computer system, arms, all to the plug in the wall. So that is just one risk that there is with that. But as I said, it doesn't preclude that you can't use a really good 3D camera system. And it doesn't preclude also that you couldn't use flexible instruments with it. So something like a FlexDex or a Human Extensions or an Art Essential, you could use any of those systems with it because the shafts. Now, some of them got 8mm shafts, so they're going to need a different adapter. But it wouldn't stop you using one of those with the system. So you could get very close, maybe 70, 80% of the way towards what you could get with a robot. So you've got, an arm that retracts an instrument. You've got rock solid 3D, HD or 4K camera system, and you'd have an ability to use a wristed or a flexible instrument during the procedure for when you need that for something like suturing or working around the back of the prostate or working down in a low pelvic space. So it wouldn't preclude you. So it would allow that. But I don't think that's really where Maestro is going to shine. I think it's going to shine in a laparoscopic environment where you want fast, rapid, lower acuity procedures where you can't justify a robot, where you can't get a full robot into the room, or where the workflow it really begs for a very quick setup and a very quick teardown. And you don't want to have to be training all the staff, and you don't want to be having to training on another system if you're a surgeon. I think that there's going to be a huge place for Maestro, and I'll talk a little bit about that later of where I think the positioning of this comes from. Before I go into that, I do want to say there is a digital piece to Maestro that was a lot more than I thought. Of course, they've got smarts now, so the vision system, if you plug the vision system in, you're able to detect things like instrument tips, and I know they're working on things like boundaries of tissue recognition and stuff. But there's a second thing that a lot of the other systems don't have. Remember, first of all, they've got a set of cameras all over the cart. I want to talk about one clever camera, and this was what I really liked, was down at the bottom of the cart. There's a camera that's looking for things on the floor. So as you're approaching the Maestro to the table, if there's a wire or a cable or something in the way, the system will know that because it's got that built-in small camera at the bottom that's checking. So that again just makes it's all about that ease of use, and you don't end up crushing a cable that you're going to have to then change. But that secondary 3D camera system that sits on the top of it, I think is going to have and give a lot of data. It's going to give a lot of data about port positioning, arm positioning. You'll be able to start gaining a lot of data. And I'm not sure that they fully worked that out yet, but I know they've got an app that's in there. So they will be able to see all kinds of data that they'll be able to do image analysis on from the outside of the patient, and they'll be able to do image analysis on the inside of the patient. And the two arms that are using the scope or the retraction instrument, they do have force sensors in them. So they'll know how much force you put on the tissue when you let go. They'll know how much force you've got on the camera. They'll know how many times you move the camera. They'll know how many times you reposition the retraction instrument. But because they've got force sensors in them and they are still robotic arms that can be driven by the system, there's another interesting thing that I saw they did. So you can do instrument tip tracking. So if I take my right-hand instrument and I set the scope tracking to that instrument tip, the scope arm, yes, it's rock solid. On its own, has the potential and can move to follow that instrument so that I always keep the area of interest in the field of view. And that's very interesting. There's lots of scope holders in the past, but people saying ESOP move up, ESOP move down, or using a pedal to move it, or using a head tracker. I think that the Maestro has found it's not unique out there. I know that Senhance has some of this as well, but using that smarts and the current 2024 capabilities of compute power to be able to track instruments and allow you that option that if you want the scope to keep your triangulated instruments in the center of the field of view, I think that's great. My understanding as well is that you can do a similar thing, and maybe it's not turned on yet, with the retraction instrument, which is because you understand the force that you set in that as a user. So you put the retraction on the tip of the gallbladder, and when you let go of the instrument, the arm will understand how much retraction force you wanted on that tissue. And what that means is that if you have the software that then just continues to apply that force as you proceed your dissection of the gallbladder, and the retraction would drop normally as the tissues become less under tension, the arm can retain that same level of tissue tension. And I don't know when they're going to bring out the scope tracking and the tissue tension, but it just gives you an inkling into what Maestro's capabilities will be and why it's a lot more than just a passive instrument holder and a passive scope holder. And I think that that's a really important piece that you have to think about. I go back and say Leonard Medical back in the 2000s, I think that they had the inklings of what people wanted, but the reason it failed is because it wasn't smart enough and it wasn't done in a way which was very practicable for the user to make it just so fluid and easy. I think what Moon has done with Maestro is they've taken that original concept and they've brought it into a modern era that makes it more fluid. It makes it faster. There's a lot of smarts in there that make the whole workflow and setup faster, and makes it a lot more of an assistant than just a passive assistant. I think it's got something in there that's going to help you to be an active assistant. The final piece that I'll talk about when I saw using it, one of my questions before I really saw the system was, but if you're holding your one instrument in the right hand and one instrument in the left hand, and you want to then move the scope manually, you have to sort of let go with one hand. And that's what you have to do. But surgeons do that all the time today in surgery. And I don't think it's going to be a major issue, but it just plagues in my mind a little bit when I look at that, about that you have to let go of an active instrument to move a non-active instrument and then come back to the instrument. But I think surgeons have done a lot of cases with this, so they seem to have worked through that workflow. So that's the general setup of Maestro. Now I want to talk a little bit about where I believe the positioning of it should be within the frame of from open to laparoscopic to assisted laparoscopy to robotic assisted surgery. The key with the positioning of any technology is you're trying to fulfill a need. And I see this as a spectrum across laparoscopy. So there's some laparoscopy where, there is no need for making it better. In the certain country, in a certain setting, with a certain group of users, straight stick manual laparoscopy with an assistant will be great, fine, and will work really well for that procedure. It's the most efficient way, it's the most cost-effective way to do that procedure. But then you're going to go to the other end of the spectrum where for a super complex case where you are in a really confined space and you want 3D visualization, you want wristed instruments, you don't mind the setup time because in an 8-hour procedure, if you've got 20 minutes of setup time, that's irrelevant compared to the procedure length. And, you're not going to be stripping that down, and get the next case through because it's a big case. So on the other spectrum of it, you want these big mainframe, high acuity, highly advanced and highly capable systems. But then you've got this grey zone in the middle, which goes from the manual laparoscopy to the kind of lower acuity robotic procedures. And you've also got different countries and healthcare systems and sites of care. When I look at the Maestro system in my head, what do I see? Well, the footprint is, let me say this the right way, is relatively small. It's not a zero footprint. It's relatively small. But it still takes up one side of the bed, which is where your assistant would take anyway. So, quid pro quo on that. It could fit absolutely into any operating room that I've ever been in my life. The other thing that I like about it, and I'm a fan of this, is that this is a floor-mounted system where the arms come up from the floor. And that as opposed to a boom-mounted system where you have a boom and the arms hang down from a boom. And the problem with boom systems is they have a height limit and they have a certain height that you've got to get to over the patient. And in some ORs around the world, that is actually a little bit of a problem. Whereas the Maestro system, because it comes from the floor up, there's no height restriction on it. That's not a problem for this system. It'll never really get much higher than a human being. So when I see this and I think to myself, okay, well, where would a sweet spot for this be? Well, if I've got a giant operating room where I'm wanting to do massive high acuity 8-hour procedures, that's not where Maestro is going to fit in my mind. Where I see it really fitting in is, I've got a smaller OR, like an outpatient department, a clinic, or an ASC, where I'm going to have fast throughput and I'm going to be doing procedures that are about, an hour in length or maybe 2 hours max. And setup time then becomes a large proportion of that entire procedure turnover time. So I would see it in high volume, high traffic settings such as an ASC or an outpatient department with slightly lower acuity procedures where the wristed instruments and the 3D is not going to be as critical and I'm not going to need staplers maybe so much being operated by the robot. I do see it in countries as well where they don't want to go all in on a robot, but they do want to have assisted laparoscopy. So I see this whole thing of it sits in the middle of high-end straight stick and low-end full mainstream robotic assisted procedures. It sits in that grey zone in between and it will stray into both, of course. But I think the sweet spot of it will be where people want to get into the robotic. They want some assistance. They don't want to have an assistant. They want rock steady vision, be that 2D or 3D, and 3D will be best in my opinion. They can do most of the things with straight stick laparoscopic instruments. Fast turnover procedures where, you'll want to get fast throughput. So setup time is really quick, really easy. And you don't want to have to retrain on yet another robot. And that's going to be a really critical piece for me. If somebody's already trained on a Da Vinci and they've already trained on a Hugo, now they've done 2 sets of training and gone up 2 learning curves, but over at the ASC, they're going to have to train on a 3rd robot. I think that's a barrier. Whereas Maestro, there is no training for the procedural use of the robot. You have a little bit of training on how to turn the thing on and turn it off. But this is not, you have to go away for 3 days to a cadaveric lab or an animal lab and go and train on it. Basically, you'll come in and in the morning you'll train on the system, and by the afternoon you are flying through Maestro procedures. And I think that's one of the game changers that's going to allow it to move in. I think they've got to be very careful that what they don't end up with is being positioned as a budget, cheaper robot that's got less capability. I think that these are two very different things. This is not a cheap budget Da Vinci or a cheap budget Hugo. This is a completely different system, and I think it's a completely different strategy that they'll need to approach. And one of the things that's really going to help with this, again, if you look at those lower acuity settings where reimbursement's not as good, where you do care about saving a surgical assistant because they cost money, where turnover is really important, then the commercial model becomes critical. And when I talked with them, one of the things that came out was that they're not going to sell the robot. This is going to be a pay-per-use. There'll be an upfront fee to get in and get going, and then there'll be a pay-per-use. And each time you use it in a procedure, you'll pay X hundred euros. And the more procedures that you do, that cost per procedure will reduce. It's clear that because they've only got 2 arms, 1 cart, no console, no tower, no image system, the cost of goods on this system is going to be dramatically less than something like an Intuitive or a Hugo. It's going to be dramatically less. So I think that their upfront cash that they're putting out, but there's still going to be cost in there. And the problem with all the price per procedure models is if you don't manage to get an initial startup fee that's at least cover your cogs, you could very quickly end up with a lot of working capital out there in the marketplace for all the place systems that you put, so that you can then get the rentals back of them, or the lease back off them, or the pay per procedure back off them. I think you have to watch out for that upfront cash going out of them. But I can see that with this system, because it is smaller, it's less complex, there's less components to it, it definitely lends itself way better than many other systems to this pay per procedure. That will just crash the barrier on access for a lot of these places like outpatient departments, clinics, ASCs, countries where their healthcare system doesn't quite afford, a big mainframe robot and the cost per case. And because the cost per case is really just the cost of the Maestro in that case, and it's a couple of hundred, you're not paying for the extra complex wristed instruments and either single life or limited life instruments. You're going to use your standard off-the-shelf laparoscopes. So again, the barrier to entry to get this into somewhere with no need to buy a new imaging system, no need to buy new instruments, not to have instruments per case. You just have the adapters and the drapes and the system. The cost per case, I think, is going to be down at the level that it needs to be to start to attack those low acuity procedures, but bring the genesis of a robotic assistance and data into those procedures at an affordable price point. So in summary, I went into looking at Moon with probably a very jaded and biased opinion, and I was shocked and surprised with what I saw, and I'm actually pleasantly surprised, because I think one of the things that I talked about a little bit is, how do we get to those lower acuity? How do we expand the number of procedures that would be acceptable to use with a robot? Well, I think this does it. I think this, from its commercial model, from its footprint, from its training, its introduction, its ease of setup, its ease of use, I think that they've been very, very smart in approaching this. It doesn't replace a Da Vinci. It doesn't replace a Hugo. It doesn't replace all straight stick. But it's going to eat in an area where they don't have to go head to head with Da Vinci. And I think that it has a really smart place in this spectrum of procedures. And I think the way that they've done it is really commendable. And again, what I would recommend to anybody is reach out to them and definitely have a go with the system, because I think you're going to be, it's the fluidity and the ease of the movement of the arms that is the game changer in the way that they allow you to use normal laparoscopy, but with robotic assistance. So thank you very much. And again, if you want to know more of what I do, then head over to howtostartupatmedtech.com, where I have the rest of the podcast and a blog. And I will catch you next time on the podcast.